Hey everybody, just wanted to make a video key so that you could see these questions work through. I know some of the graphing problems might not be the most straightforward for you still, so just wanted to show you guys some stuff. So, take a look at this first one. This is in standard form. Easiest way we've learned to graph from standard form is find that vertex first, right? So we're going to go negative b over 2a. That's where vertex x value comes from specifically, right? We could say x is equal to negative b over 2a for the vertex. So then I'm going to take negative 6, and then I'm going to divide it by 2 times the a value, which is 2, which will give us negative 6 over 4, which then we can reduce to negative 3 halves. All right? Once you find that, that's just the x. So what do we do with x values to find y's? We just plug them in, right? So we're going to plug in negative 3 halves. So I'm going to have 2 times negative 3 halves squared plus 6 times negative 3 halves plus 1. Then we'll do some math here. We got 2 times 9 halves when we square negative 3 halves. And then that's going to be minus 6 and 2 would cancel. So we got 3. So minus 9 and then plus 1. Sorry, this should be 9/4, right? We square the 2 in the bottom, 9/4. We can see that 2 and 4 would cancel here. That would be just 9 halves. So this is really 4.5 minus 9 plus 1. So what's that going to give us? Did I do that right? Why does that feel off? Should be negative 3.5. I think if I did that right. Yeah, negative 9 plus 1 is 8. So that's negative 8, and then negative 8 and 4.5 would make negative 3.5. Yeah, so we're good. So our vertex is at negative 3 halves, comma negative 3.5, just like this. So the negative 3 halves would be negative 1, or actually I guess, depending on how you count it, you can count it in halves, right? Here's 1 half, 2 halves, 3 halves. So there's negative 3 and a half. 3 halves, sorry. And then negative 3.5, 1, 2, 3, and then another 0.5. So we're right in the middle of this circle right here. So there's our vertex. Next easiest point to find from that, we have our y-intercept of positive 1, so we can plot that as well. And that's specifically half and 1, so 1.5 from the middle, so we'll go half and then 1. We can graph that as well, right across there. And then I honestly think the easiest way to find the last point here is just plug in a value, right? Like we don't have a point at negative 1 yet. So why not just plug in negative 1? So we'll go 2 times negative 1 squared plus 6 times negative 1 plus 1. So this will be 2 times 1 minus 6 plus 1. So it's 2 minus 6 plus 1. 2 minus 6 gives us negative 4 plus 1. So we're at negative 3. Right, so at negative 1, we're at negative 3. And then that means at negative 2, we'd also be at negative 3. And so now we have 5 points. We can graph this thing. So the graph will look something like this. Say you forget that negative b over 2a is how you find the x value of the vertex. Just start plugging in points. Like how we plugged in negative 1 and we got out negative 3. That gave us the point negative 1 comma negative 3. Just start plugging in other points, like plug in 0. See what you get out, right? Hopefully you get out 1, because we saw that that's the y-intercept. Plug in 1 and see what value you get out. Plug in 2 and see what value you get out, right? That's always the easiest way. If you don't know anything about the graph, just start plugging in x values. Okay, next one. Next one gives us the vertex, right? So the vertex is right here at negative 2, negative 4, specifically the h shift and the k shift. So I'm going to plot that. Negative 2, negative 4. Puts us here. And then the easiest way after this is to look at the a value and then use that to graph the rest of this graph. So I'm thinking x squared equals y. That's our parent function, so we have x and y. If you would plug 1 into x squared, you would get out 1. But then we'd need to multiply by the a value of 2, so times 2. So that gives us a y value of 2. So what does this mean to me? It means when I go to the right 1, I should go up 2. And this is from the vertex. So right here, if I go to the right one of the vertex, it should go up 2. So there's my first point, and then I can just graph right across. And then we'll just do that again. Like, so if I take a parent function, I plug in 2, right? 2 squared is going to give me out 4, and then I have to multiply it by the a value of 2, so that tells me 8. So this is saying if I go to the right 2, I should go up 8 from the vertex. So right 2 puts me here, and then I'm going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8 puts me right there, and then graph across the axis of symmetry, and then here is my graph in vertex form. Just like that. If you struggle with that, go back to the first space, right? -1, let's plug in -1 into this and get out a y value. So you get -1 comma some y value. Hopefully you should get out -2 if you do it properly, right? But just start plugging in x's and getting out y's. This next one, again, we're back into vertex form. So our vertex here is +3, +2. So I'll go right 3, 1, 2, 3, and then up 2. Puts me here. And then we can use the a value. So if you're really good with the a value, you can see that this is just telling us to make all of our y's negative. So instead of going up 1 and to the right 1, it's going to go down 1 to the right 1. Then we can graph here. Normally, the next point should go up 4, 1, 2, 3, 4, because it's x squared. But instead, it's just making it negative, so it's going to go down 4. So 1, 2, 3, 4 puts us here and here. And there's our graph. And then the last one right here, this is intercept form, right? So one of the intercepts is 3, 0. The other intercept is 5, 0. They come from the factors. So we can graph those points. So 1, 2, 3, 4, 5. So there's those 2 points. Once you graph them, you can see, okay, the axis of symmetry is right here in the dead center of those two, right at 4, right? So to find the vertex, we just need to plug in 4. So we're going to say 2 times 4 minus 3 times 4 minus 5. So this is 2, 4 minus 3 is 1, 4 minus 5 is -1. So this is really just 2 times -1, which gives us -2. So our vertex is at 4, -2. We'll graph that, 1, 2, puts us there. And then again, one more point. Depending on how well you know a value, you can use this to graph. As you can see, if you go to the right 1, it goes up 2. Normally, as you go to the right 2, it should go up 4. So it should go here, but instead, we're multiplying this y value by 2. So it's going to go up 5, 6, 7, 8. There's my last point. All right, so there's my graph in intercept form. That wasn't great. Let me try again. Come down through there. Nope. Struggling at graphing a little bit. Okay, that's good. Okay, on to the next thing, imaginary numbers. So, adding and subtracting imaginary numbers, as straightforward as it can be, combine like terms, okay? Make sure you see this plus sign. Plus sign means to add, so I'm going to combine 1 with 3, right? That'll give me 4. And then I'll combine I plus I, that should give me a positive 2I. And you're literally done. There's no more you need to do to that problem, okay? Subtracting complex numbers, you have to be a little bit more careful here. All right, I highly recommend let's distribute the negative, okay, and then drop all the parentheses. So -4 minus I, -4 minus 5I. Now you can see, okay, -I minus 5I, that's going to give us -6I. And then we're also going to have this -4 minus 4, so that's going to give us -8. Okay, so there's my... That's my complex number in standard form. Remember, standard form is A plus BI. Multiplying the distributive property works just as any other type of multiplying distributive property. So we'd say 12I plus 6I squared, because I times I would make that squared I. Hopefully you know by now that I squared is -1, right? So this is really 6 times -1. So we have 12I minus 6. Standard form, yes, I would take it. It's fine. Normally, you would put the real number first and then the imaginary number second, but I would take that. I'm not going to count that wrong. All right. Next one, foiling out things. So here we have 2 times 4 gives us 8. We have 2 times 2i gives us positive 4i. We have I times 4, which gives us positive 4i. And then we have I times 2i, which gives us positive 2i squared. When you do this, you can see that the i's in the middle will go together. So this is 8i. This I squared is really just negative 1, right? So this entire thing is just negative 2. So then we can combine 8 with negative 2, and we can get out 6. So 6 plus 8i. This one is just making sure, hey, I know I'm squaring it, but that doesn't mean distribute. Do not do that. Instead, you need to write out both of the factors here. This is 2 plus I times 2 plus I. And then we're foiling. So 4, 2i, 2i, and then I squared. Again, I squared being negative 1. So 4 and negative 1 make 3 plus 4i. This last one here, we have to basically rationalize this because we don't like imaginary numbers in the denominator. That's like having a radical in the denominator because I is radical negative 1, right? So we have to get that out of there. In order to do that, we had to multiply by the complex conjugate. So we're going to multiply by 3 minus 4i and 3 minus 4i in the top and bottom. And then this is a lot of foiling. The reason we have to switch the sign in the middle is because this causes middle terms to cancel. Right, so let's FOIL this real quick. I'll just go here. 3 times 3 gives us 9. The middle is going to be positive 12i and negative 12i. And then the last term will be 16i squared when we go 4 times 4 and I times I. As anticipated, middle terms cancel, right? So our bottom is just 9 plus 16 because this is going to be negative 16 times negative 1 makes positive 16, which means the bottom is just 25. In the top, more foiling has to happen. We have 6, we have negative 3i, we have negative 8i, and then we have positive 4i squared. So this is going to become negative 4, right? So 6 minus 4 gives us 2, and then negative 3 and negative 8 make negative 11i. It does tell us to put this into standard form, so we have to split this fraction. So in standard form, this would be 2 over 25 minus 11 over 25i. And there's your answer in standard form. Not sure why my pencil is kind of laggy right now. Okay, last thing with imaginary numbers here, we're taking a look at this. Finding the absolute value / magnitude of a complex number, it's this, remember? So the reason this is kind of confusing looking is because I didn't give you a graph. Normally I would say graph it. So we have the graph of this thing. Imaginary numbers are on the y-axis, real numbers are on the x-axis. So this is telling us go to the right 3 and then down 4. Magnitude is just the distance from 0 to this point that we have, okay? And so if you remember with distance, we can build a right triangle with a distance of 3 here and a distance of 4 here. And then we can just say 3 squared plus 4 squared equals the distance that we want squared, see? So that's going to be 9 plus 16 equals c squared. So that's 25 equals c squared square root. C is equal to 5, not plus or minus this time because distance is only positive. Okay. Same thing is going to happen to 8. You only need the numbers, so 1 and radical 3. So I'm going to say 1 squared plus radical 3 squared equals c squared. So that's 1 plus 3 because square and square root will cancel with each other. So this is 4 equals c squared. And then we square root to see that c, the distance, is equal to 2, right? So that is literally the absolute value of 1 minus I radical 3 is 2. All right, solve by completing the square. We're here, right? This is what we just finished up. Remember, we have to move everything to one side. X squared minus 10x plus 10 equals 0. And now because a is 1, we can just go through the completing the square process, right? We're going to take negative 10 and cut it in half to give us negative 5. So then negative 5, we'll take that and we'll square it to give us 25. That's what we fill in. So x squared minus 10x plus 25 minus 25 plus 10 is equal to 0. This whole section factors because we made a perfect square trinomial. X minus 5 squared would be the factor there. Or factors, I guess, because it's squared. Negative 25 and 10 is going to give us negative 15 is equal to 0. And then to finish solving, we need to just get x by itself. So let's add this 15. So we got x minus 5 squared is equal to 15. Square root both sides. X minus 5 is equal to plus or minus the square root of 15. And then we'll add the 5. So x is equal to 5 plus or minus the square root of 15. Beautiful. Taking a look at 1 with solving where there is an a value, right? Here you're just going to divide everything by a. Effectively, this just gets rid of the a value for us, but doesn't actually complicate the problem. It makes it so that it's more doable, okay? Because now we have x squared minus x plus 3 equals 0. And we got rid of our a values so that it's just 1. And we can do the completing the square process with no other issues here. All right, so we have negative 1 cut in half, and then we'll square it, so that's 1/4. So we'll say x squared minus x plus 1/4 minus 1/4 plus 3 is equal to 0. Again, this will factor, perfect square trinomial, so x minus 1/2 squared. A little bit more involved to add negative 1/4 to 3, right? We need to put 3 in fourths, so we'll go 4 over 4. Which will make 12 fourths. So negative 1/4 plus 12 fourths will give us positive 11 fourths is equal to 0. Solving for x, we'll move this to the other side through minusing. So we'll say x minus 1/2 squared equals negative 11 fourths. Square root both sides. X minus 1/2 is equal to plus or minus. The negative sign under the radical becomes an I, and we'll move it outside, so I radical 11. In the bottom of this, the square root of 4 is just 2, so we can put that 2 right there. Lastly, we just add the 1/2, and then the problem's done. X equals 1/2 plus or minus I radical 11 divided by 2. Next, we have converting to vertex form. Wants us to also identify the vertex. So in this problem, again, we can't complete the square right away because we have an a value on there. A has to be 1 in order to complete the square. I taught it a little differently this year, so I'm going to just keep showing that way because I actually like it a lot. We're going to take the a value, and we're just going to take it off everything. And if we divide the whole right side by 7, it means we need to divide the left side by 7. To keep the equation balanced, right? So we're going to say y over 7 is equal to x squared plus 2x plus 11/7. And then we can just work from here. Normal completing the square process, as always, we take 2, cut it in half, gives us 1, 1 squared, still 1. So we have y over 7 is equal to x squared plus 2x plus 1 minus 1. Plus 11/7. I know that we're already going to have to combine this together, so let's just multiply that by 7 over 7. So that's negative 7/7. And then we're going to add 11/7 to it, so that's going to give us positive 4/7. This will factor x plus 1 squared equals y over 7. And then to get it in vertex form, we got to re-isolate y. So let's just multiply the 7 back to the other side. So now we have y equals 7, x plus 1 squared plus 4, because these 7s will just cancel. How you know if you did the a value properly is if the a value at the beginning matches the a value at the end. So looks like we did do everything okay. Our vertex here would be negative 1, comma 4. It's always opposite of that h value that shows up. And there we go. 12, this one actually doesn't even have an a value on it, so we just go right into the completing the square process. So we'll say x squared minus 8x, and then we're squaring 4 here. So we'll go positive 16, negative 16 plus 10 equals y. So y equals x minus 4 squared. And then we'll say minus 6. So then our vertex is just at 4 comma negative 6. A little bit easier when there's no a value on that thing. Alrighty, last question. So this is the picture frame question. Granted, it's talking about a garden. Okay, just because it's a garden doesn't mean it's any different than how our picture frame question worked. But you have a rectangular garden that is 2 feet by 3 feet. So let's draw that. We got 2 feet here. We got 3 feet here. 2 by 3. Love that. You have 50 square feet of wood to create a deck with uniform width around the border. All right, so that means, okay, we have x and x. We're also going to have it come off x and x, right? That would be a uniform width around everything. All right, there is our deck that we're building around there. Let me move these in so I can finish these lines. There's our deck that's around our garden. Okay. It says, what should the width of this deck be? So it wants us to figure out what is x, right? So setup and work. We now know that the distance of this long side, because it's a uniform width, is going to be x plus x, right? Because it's got x on both ends. So that's 2x. And then plus the middle and the distance in the middle, which is 2. We know the distance on this side is going to be, again, x on one side, x on the other. So that's 2x. And then plus the 3 in the middle. So the dimensions of the big rectangle with the deck around it is 2x plus 2 times 2x plus 3. Now, we need to set this equal to the area of the big rectangle. Well, the nice part is we know the area of the blue. Let's grab this blue. So we know this blue area right here, right? Because we have 2 times 3. It tells us that it's 6, okay? We also know the area of the purple, which is the distance around the blue, right? That area is actually just in the problem. It tells us we have 50 square feet of wood that we're going to build the deck with. So then we're going to take the 6 that we found from 2 times 3, and we're going to add it to the 50 that we had at the beginning to give us 56. On the left side here, we need to FOIL stuff out. So this is going to be 4x squared plus 4x plus 6x plus 6. If I did that right, 4x squared, 6x, 4x, 6. Yeah, should be good. So that's going to be 4x squared plus 10x. Let's minus the 56 right here to give us negative 50 is equal to 0. Nice thing about this is we can see 2 comes out of all of these. So let's try to make our lives a little easier here. 2x squared plus 5x minus 25 is equal to 0. And then these should factor. I think I made these questions nice enough that they factor almost all the time. So we have 2x and x, positive in the middle, so I'm guessing positive here, negative here. I guess the only options are 5, right? So 5 and 5 to make 25. So let's double check. That's positive 10x, negative 5x. Yeah, makes positive 5x. So our solutions are x equals 5 halves or negative 5. In this case, we're talking about real life. So right here, we got 5 halves and our units were feet. So the width will be 5 halves or 5 halves or 2.5, right? I guess probably 2.5 makes more sense if we're talking distance. All right. Okay, that's it. That's everything that'll be on the quiz. If you have any questions, you could just ask them before. The quiz is not terribly long. Tomorrow, just front and back. Yeah, so if you have any questions, feel free to ask them at the beginning of class tomorrow. We can buff out some last-minute things. Anyway, study hard tonight. Hope you have a good evening. See ya.